Okay, welcome back. We're about to do problem 3-1. First thing we need to do is enter the information that is given. First we have a 200 kilogram crate. So here we calculate the newtons. So 200 kilograms times the acceleration of gravity, which is 9.80665 meters per second square, and that gives you 1961.33 newtons. So just keep that in mind when you have kilograms. You have to convert them to newtons. And then my first force here, I'm gonna name it BC, and the second unknown force here is BA. BC and BA. B is the center. That's what I started with B. And here we can name this crate. So for BC, this is given as degrees, but it's 180 degrees from the positive x-axis. So this is what we're measuring. For force BA, it's given in x, y, and L. And in this case, x is the unknown. We don't know what it is, but we're given that y is 0.75 and the length is 1.5. So now this would be our free body diagram with the crate pointing straight down. This is 270 degrees, and this is 0.75 and 1.5, and this again is 180 degrees. So what we have here is we did a few calculations here. So for force 1 is given as degrees, 180 degrees. If you wanted to resolve it into components, you have cosine of 180 is -1, sine of 180 is 0. So the y component of this force here is going to be 0, and then unit length 1. For vector 2, if you want to calculate the x, you can do so. It's 1.5 square minus 0.75 square. That gives you 1.29, and y is given 0.75, length is 1.5, and the degrees can be calculated as follows. This is the arc sine of 0.75 divided by 1.5, which is 30 degrees. And for vector 3, it's 270 degrees. So the cosine of 270, it's 0. So for this vector here, for this force that is represented by the crate, this is going to have an x component of 0. And the sine of 270 is -1. So the f component is going to be pointed straight down, and the length, the unit length, is just 1, and again degrees, 270 degrees. And the force 3 I already showed you, 200 kilograms times 9.8 gives you 1961.33 newtons. And so what we do next is we sum all the forces in the x and y direction, and we can start with force BC. So cosine of 180 degrees times force BC plus 1.3 here, 1.299 divided by 1.5 times force BA plus the cosine of 270 times 19.6133. So if you look back here, this is 1.299. This is the x component here that we calculated. You can also use cosine of 30 degrees either way. So 1.29 divided by 1.5 or cosine of 30 degrees, it's going to be the same. And in the y direction, you have the sine of 180 degrees times force BC. So this here, it's 0, and plus 0.75 divided by 1.5 times force BA plus the sine of 270 times 19.61.33, and that is equal to 0. So the summation of all the forces in the x direction is equal to 0, and the summation of all the forces in the y direction is equal to 0. And now we have two equations with two unknowns. The two unknowns being magnitude of force BC and force BA. And the simplest way to solve this is to use an inverse matrix. Don't get all scared and think that you can't do it. It's real simple to do. Well, not by hand, I take that back, but if you have a TI-89, you just set up your equations, put the matrix into the TI-89, TI-89 titanium, TI-92 and Voyage, and you will be done. And if you get good at this kind of problems, you can solve them in less than 4 minutes. I am not exaggerating. So what you do is you have to set up two matrices. So in one matrix you have the coefficients of your unknown variables, and you raise that to the -1, so this represents an inverse matrix. Then you multiply that matrix times your knowns. So this here, it's negative cosine of 270 and negative sine of 270 times 19.61, and the reason for that being negative is because you have actually rewritten these equations, and you have taken this whole quantity here and you're taking it to the other side. So when you take it to the other side, it's negative, and the same thing with this quantity. It will be negative sine of 270 is taken to the other side of the equation, and this is going to equal another matrix, which is going to give you two numbers. In this case, it's going to be force BC and force BA. So doing an inverse by hand, it takes some practice, and that alone will take you about 5 minutes to do an inverse matrix if you're good at it. In some cases it might take you 10 minutes and you might not even get the right answer. So we're not doing an inverse matrix by hand. What we're doing is we're using our graphing calculator, TI-89, titanium, TI-92 and Voyage. These two are the most common ones. If you're an engineering student, I would 300% recommend that you have one of these calculators, because you need them. They're damn good calculators. I apologize for the last, I didn't mean to swear. And this TI-92 and Voyage, TI-92 is older. It does the exact same thing as these two, and so does this one. They just have more memory, and they're less common and sometimes more expensive. So don't even try to buy this. My recommendation is TI-89. TI-89 titanium is probably going to be more expensive, and I don't think it's worth the upgrade from TI-89 to TI-89 titanium. TI-89, I've actually had all these 4 calculators, and from my personal experience, right here, this is what you need, TI-89. So anyways, let's get back on track and let's finish this problem. So in your TI-89, if you're in your home screen, what you do is you enter this matrix here, these two matrix. So this first matrix times this second matrix, and the way you do it is you type this in just like you see it here, and I'm gonna explain it to you. If you've never done an inverse matrix in your TI-89, this is a great time for you to start learning how to do this, because every class that you have, you're probably gonna end up solving systems of equations, and inverse matrix is the fastest way, quick, less than 5 minutes. So for this first matrix, you use the bracket cosine of 180 comma 1.299 divided by 1.5, and this represents your first row here for your first matrix. And then to start the second row, you have to separate it by a semicolon. So then you start your second row of your first matrix. So you have sine of 180 comma 0.75 divided by 1.5. You can include the braces here, and the sine and cosine, they are required. And then you close your matrix. You're done with your first matrix, and then you raise it to the -1. So this here is a negative, not a minus, it's a negative. And this symbol here is on your TI-89. It should be above the division symbol. Yep, it's right above the division symbol. So you're raising it to the -1, which is below the number 3 on your keypad on your TI-89, and 1, and then this is times, and this here represents your second matrix. So to start the second matrix, you use a bracket, and then you enter your first row, negative cosine of 270 times 1961.33, and then your second row for your second matrix, you separate it by a semicolon. So negative sine of 270 times 1961.33, and you close it. You close your bracket, and once you have this enter your TI-89, you press enter. When you press enter, this third matrix shows up. It doesn't say force BC is equal to, it will just have the numbers here. It will have your answers, and this represents your force BC and your force BA. So after entering this matrix, these two matrices into your TI-89, press enter, and you're going to get the answer for your two unknowns. So the inverse matrix is the fastest way. This problem from start to finish, if you have this method down, I guarantee you're going to finish this problem in less than 5 minutes. In less than 5 minutes if you're really good. So it takes a little bit of practice, but I'm not exaggerating. If you're an engineering student, you should be able to solve this problem, set it up from beginning to end in less than 5 minutes. Well, thanks for watching. If you guys have any more suggestions for me, if you want to see another method, I can include other methods in my solutions. For example, we can do Kramer's rules, we can do Gauss-Jordan elimination, we can do substitution, and substitution takes longer too, but whatever method you guys want me to include in the solutions, I will include it, and try to enhance. I'm basically trying to enhance your knowledge of solving and setting up these kind of problems in statics. So any feedback is welcome. Well, thank you for watching, and hope to hear from you soon.